Go ahead and get started with web app security real quick. So again, this is just kind of a quick introduction because I want to get into the demo side of stuff, but the main concept behind web app security is just that any user inputs can't be trusted, even if it's just like something from a drop-down menu or just like clicking a button. It can, might as well just make sure that it can be somehow malicious. So you want to make sure that user input's processed correctly. A good list that kind of keeps track of what web app security is in the modern days is a list called the Owasp Top 10. It updated every few years and it's kind of talk about like the 10 biggest attacks that are hitting websites and causing them to do bad things. A lot of these things kind of are agnostic of what language web app is written in, but if something's written in PHP, it's just going to be more insecure than something that's written in like Python or Go or anything else really. Maybe not JavaScript, that's probably about just as bad. And a lot of web app hacking can be done just using a web browser. So just like Firefox with some extensions is all you kind of need. There are some fancier things they can do just using a terminal, but for the most part, all you really need is just a web browser. So probably most of what I'm going to be doing is a demo that you guys can all follow along with. To connect to a web server that I'm running on my laptop, just go to connect to the IASG Wi-Fi and go to 10.26.52.187. And from there, you should see a login prompt, and the login credentials for that are admin and password. And when you do that, you should get a screen that looks something like this. I'll zoom in a little bit, that's not in. And kind of the idea here is that it's a series of different challenges that are vulnerable to a type of attack here on the left. Just select one, and then from here, as a simple web page, just take some sort of input, and you can kind of try and break it from there. There are 4 difficulty levels, easy, medium, hard, and impossible. And right now, this is set to easy. Yeah. Login stuff is on the board as well if you're not logged in just yet. First thing to cover is command injection. This is what happens when you have a web app that takes user inputs and it uses that input to run some sort of system command. It could be anything. In this case, it's the ping command. This example just takes a user to type in an IP address, and then we'll try to run ping on that target. And the attack here comes where if you use some sort of command line syntax like a semicolon to just end that command that's supposed to be running and run your own command. There's many different ways to do this. The most common way is just to append a semicolon and then type your own command. So if we go to the command injection section here, it's giving me a prompt that says ping a device, and if you enter in just any IP address, in this case we'll do 1111, it will run for a bit and it will spit out the output of what would happen if you just typed that in a Linux shell. So this is taking a user input and just kind of throwing it into a command. So from here we can just type a semicolon to end that ping command, and it won't work, which is fine as far as we're concerned. And just run a simple command like pwd, and we can see that we have a command injection and it's now printing the working directory the web app is running in. From here you can do some more fun things like catting out etc password and getting the contents of that file. You can also from here establish a reverse shell. I won't try and do that because it's kind of finicky on DVWA, but you could just drop the shell in the box from here. So to avoid having this be exploited, it's we're kind of like not super straightforward as far as how you do it, but basically if you're taking a string and you're throwing it into a command, you want to make sure that any command or any character that can be used for command injection is replaced with an empty space. So in this case, we have an array that is full of substitutions, and if it includes the and symbol, semicolon, the pipe, $sign, parentheses, tick marks, which are all different ways that you can run a second command inside a bash, just replace it with nothing. And I think this is something you have to do no matter what backend you're running. Like, this isn't just a PHP thing. Any sort of language you're running, you need to sanitize it for command injection. Another common vulnerability is in file uploads. This is what happens when you have a website and it just allows end users to upload a file. For example, if they can upload a profile picture or something, you want them to just be able to upload pictures, but if you're not doing anything to actually restrict that, they can just upload whatever they want. And kind of the main danger here is if you can upload web shells, which is just kind of a PHP page where you can run arbitrary commands, and then you're just kind of in the same boat we were before, where now you have command injection on the page. If you're running a offensive security-based Linux distro, then you have a lot of web shells available at your disposal in user share web shells, I think, and from there you can just pick them based on what language the web app is running in. Or if you forget to prepare for your demo, you can just kind of Google for one. And you can just find one on GitHub real easy. This is not the one I wanted. And can't really see that, but this is only a 3-line program, and the first 2 lines are comments. So uploading a backdoor isn't all too difficult. Nope. I cannot type. Again. There we go, okay. So, going to go to the file upload section of the website, and it's just going to allow us to upload a file. In this case, it can just be whatever we want. So we're going to upload our backdoor.php file, and it's going to tell us that the file has been successfully uploaded to that directory. And then from here, if we just visit that page, we won't see anything here, but if we append $CMD equals and then some like PWD, it will print out the contents of PWD. And then from here, same as before, cat etsy password, and now you are stealing files from your web server. There are some more fancier ones that you can do. The one on the screen here is called C99.php. IceAge has put this specific web shell into multiple PHP web apps that they've run, and a lot of teams don't audit their code enough to notice that, hey, our website has a web shell in it, we should delete that. But this one's a bit more fancy in that it actually has like a front end, but you don't really need that. Again, 1 line of PHP is all you kind of need to upload a fake web shell. So, securing against file, or locking down file upload, I guess, is kind of a bit more difficult for security teams to do, but the easiest way to do this is to just have a whitelist of file extensions out to be uploaded. So if you're running something like, if it's uploading pictures, then say it has to be a JPEG or a PNG. If it's a video, it has to be an AVI format, something like that, so that they can't be uploading, PHP files. And it's a bit, I'm not going to get too much into it, but check the entire file name, because sometimes they'll be able to get away with this by doing file names of like backdoor.php.jpg, and then using a program like Burp Suite to remove the ending JPEG tag, so it's uploaded as a PHP file. And then another thing to do is, to secure it, is to perform a file integrity checks to ensure that the file being uploaded is actually an image and doesn't just have like an image file extension on it. In the case of images, you could run the Linux command file, which tells you what file the file is, but all this does, it looks like the first 2 bytes of the file and says, oh, based on this, it's probably an image, and that can be spoofed as well. So what you want to do is something like try to resize an image and then unresize it, and if that works and you don't get any errors, then it's probably an image. If you try to resize PHP script, it's going to throw some sort of error, and that's a good sign it's not actually a picture going on. All right. Not as much of a demo for this one, but when it comes to cookies, if you're not familiar with cookies, they're kind of something that websites use to track users as they go across websites. This is useful, especially for websites where you have to log into something, because you don't want to have to re-log in every single time you go to a different page. You just have that cookie stored in your page that says this is what user I'm currently logged into as. And since the cookie is stored on your computer, you get to decide what value it is. Just because the server says this is what the cookie is and this is what value the cookie is means that's what you have to go by. An easy way to change your cookie value is through browser extensions. You can technically just go into Firefox and go into the memory of the thing and just change it from there, but there are browser extensions that can make this a little bit easier. The one that's most popular on Chrome is called Edit This Cookie, and for Firefox it's Cookie Editor, I believe. There's a ton of extensions that allow you to do this. They all do basically the same thing. Some things I want to look for when you're looking at cookies to see if there's any sort of things you can exploit. If there's a cookie and its name is admin and it's set to false, just set that cookie to true and now you're an admin. Kind of trivial, but these things happen. So the demo for this one isn't as good. I think it's just kind of like, I don't even think it's really any demo, it's just like looking at cookies, but this is the weak session IDs section. All this will do is you click at the thing and generates a cookie, which isn't too cool, but looking at file extension or web extensions, this is the one I'm using. It's called Cookie Editor. You can't really see this, the font's kind of small, but there's one at the top, and it's called DVWA session, and it's set to a value of 1, and that is supposed to be the cookie that identifies who I am. So this is on like a real website. If I just change that cookie value to 2, and we're now logged into somebody else, or about 3 or 0 or something like that. And so, yeah, you just kind of want to make sure that your cookies aren't just like telling exactly what they do as far as like how they're checking your session. I don't want to be able to look at my session and see, oh, this is how it determines it's me, and then this is how it will determine I'm somebody else. So don't just have a cookie that like stores your the username to check somebody, something like that. You want to make it a bit more obscure when you're checking people. And most web or most programming languages should have some sort of function called like session ID that is supposed to be fairly random and will track users pretty well. So don't reinvent the wheel when tracking users. Just give them a PHP session ID or whatever language you're using, and that should be what you have to do. Right. Really popular web app attack is SQL injection. This is kind of the same concept as command injection, where it's taking user input and it's running a command, and then we can kind of use some funny syntax to make it do what we want it to do. SQL stands for Standard Query Language. This is the language that most databases run on. MySQL, Maria, Postgres, all run on or they all use SQL as their language backend, I guess. And kind of the most common SQL injection attack is a simple apostrophe or apostrophe 1 equals 1 statement. And what this will do is it's mostly used to bypass login attempts. So for example, in this case, if you look at this piece of code, it's trying to check a database and it will run a SQL statement. And this is a SQL, kind of the way SQL syntax works is just kind of reads like a sentence. And it's select first name, last name from users where user ID equals, and then user input. So it's going to go through a database called users, and it's going to output the first name and last name that is stored, and it's going to do this wherever the user ID is equal to 1. And the way we can attack this is by using this or 1 equals 1 statement as our payload. And then when we do, kind of what's going on in the statement is going to say, select first name, last name from users, where user ID equals blank, or where 1 equals 1. So it's going to go through every single statement in the table, and it's going to look at it and say, okay, the user ID is not equal to blank. However, 1 equals 1, so this is true. And it's going to print out the entire contents of the table, or at least the first 2 columns of the table. Another use for this is for logins. You set the username to the person you want to log in as, and you set the password to or 1 equals 1, and it will say, well, the username is correct for this user, but the password's wrong, but 1 equals 1, so we're going to log this user in. Okay, and then for the demo here, the SQL injection section, the idea here is you just submit someone's user ID, like say 1, and it will output the information on them. And let's say we want to just dump the table for every single user ID. Let's throw that in there. And it'll output for all 5 users. So that's kind of cool. One thing that I kind of wanted to get working for this demo, but it wanted to just change the syntax on me for some reason, is a program called SQL Map. SQL Map will automatically scan a website to see if a certain input is vulnerable to SQL injection. And if it is, you can also use that to drop to shell on that, and then you have a shell not on the box itself, but a shell in the database, and then you just kind of have unrestricted access to the database that's running. I think in 231 you use SQL Map, but I can't remember. So when it comes to preventing SQL injection, most programming languages kind of do this for you, but PHP does not. It's kind of the, really the only one to know of that doesn't. PHP and I think JavaScript don't prevent SQL injection. And kind of the way you do this is through something called prepared statements. And it's kind of just magic, honestly. You just have to make your SQL query in the way that PHP wants you to, where first you prepare it and you kind of define the statement out in this first line. And in the second line, you bind a variable to the parts of the statement that is a user input, and then you execute it. So like, it's really not a whole lot different than what you do by default. You just kind of got to go through this process to make it more secure. PHP does have a method called MySQI real escape string, which is supposed to just kind of... Yeah, but it doesn't work too well because there's like so many different ways you can do SQL injection. You can do this with only like 4 characters that are, none of them are apostrophes. So it works in some cases, but not all of them. But it's better than nothing, I guess. I don't know. Prepared statements are kind of the way to go. A really popular one is XSS or cross-site scripting. The idea here is that if there's some user input and it's just kind of being reflected out as some sort of HTML, then you can use your user input to carefully craft a chunk of JavaScript by using the script tags in HTML. The main 2 types of cross-site scripting are reflected and stored. With reflected, you just type something and then it kind of just spits it back at you. And then once you refresh the page, then it's just gone. Reflected is not super useful because basically the only way to kind of get anything out of that is to have somebody click on a link that runs the XSS script, and it's kind of difficult to do. An easier way to do it is with stored cross-site scripting, and this is where the input you're doing is actually stored in the website's database, and then when other people visit the page, they'll see it too. You can think about this like, say, in a comments section, where you just type the comments and then it's displayed in the page whenever people view the page. And this one's actually more serious because if you are good at cross-site scripting, you can do things like redirecting people to phishing websites or steal their cookies or stuff like that. So to demo this one, I probably should have had the payload in that slide, but there is a third category called DOM, which isn't as talked about as much, but is this how I can zoom in? Okay, I can zoom in more. So simple web up here, it asks for your name. So if I just enter it, then it'll say hello and then my name. And actually I haven't tried this, but if you try to do some like fancy HTML formatting tags, like to make it bold, then you can make your name be bold when it flicks back at you, which is kind of cool, but not something you really need. And the exploitation here comes when you do the script tag to say, I'm going to run some JavaScript now, and you kind of the basic, I guess, hello world of cross-site scripting is just to alert 1, and then this will make a nice pop-up which displays a 1, which that's not really like useful, but if you are good with JavaScript, I am not good with JavaScript, you can start redirecting people to different pages, steal their cookies. This is more kind of like a client-side attack. Like you can't use this to really get onto a box inherently, but it still is a security issue. And then, good work, Jack, and I'm guessing Jack. But for the stored cross-site scripting, as you can see, if someone else visits the page, they will see it as well. Script. I already forgot how to do this. But this is a guestbook type application. It's just a comment page. And then every time I load the page, I see 1, 2, 3 different error messages. And then if everybody else loads this page, you will see them as well. So that's a bit more serious because I'm just clicking on a website as I normally would, and all of a sudden there's cross-site scripting going on. I would demo that more, but I'm not as good as JavaScript. I think last year I had somebody redirect everybody to an archived version of chris.com whenever someone went to a page. Prevention of cross-site scripting is actually kind of straightforward for how common it is on websites. For PHP, there's a specific method called HTML special cars. You can kind of see it on this second last line that's not a comment, where they just take, the idea of this script is that they're taking user input and they're storing in a variable called name, and then they're running HTML special cars on it to kind of just escape the string away. And this one actually does work. unlike the way that they escape strings for SQL. For other languages, I think if you're running like a more modern web app like Django and Python, then you have to disable security measures that it's got in place to actually have cross-site scripting work. So this is, again, kind of more of a PHP issue, and I think JavaScript as well, maybe some other older languages. You can also fix cross-site scripting not in the code itself, but in your server's configuration. This is through the content security policy. This is just something you can edit in the Apache or Nginx configs. I don't know a whole lot about content security policy, but it's basically just one line that says disallow scripting. It's kind of straightforward, but a lot of people aren't doing it. So I think that's all I have for the actual demo part, but there are some other types of injections that kind of just follow the same format of you're taking user input and you're throwing it into some sort of, you're running it somewhere and you're not evaluating it as being potentially malicious. One method for Python is this command called eval, and the idea here is that you kind of build a string to have that string run as Python code, and then you just run eval on it and then it runs. And it's kind of the same thing. It's just command injection, but for Python code. This isn't necessarily just like a web-specific thing. Like any sort of Python application you have running could be vulnerable if they're running eval and eval is taking user input. So if you see this in Python ever being used, just delete it and do a better, just write the code better, I guess. Like you don't need eval to do anything. XXE is XML external entities. This comes into play when you have a website that allows users to upload XML files, which I've actually never seen before, but I don't know, maybe it's not close enough. The idea here with XML is that XML parsers can just basically run commands, and you can just have your XML say something like print out Etsy password, and it just does. This is kind of a newer thing. This just got added to the Owasp top 10 back in 2017, and it hasn't been on there before that, so XXE is still kind of a new concept, I guess. Similar concepts before, just run a command that says no XXE and then you're good. And then Ldap injection. This applies if you're having some sort of website that is logging people on and it's using Ldap as kind of like a backend for Active Directory or single sign-on. And you can just, again, it's like SQL injection, just use some Ldap queries, throw some Ldap syntax into your login, and then you're logged in. I haven't actually seen Ldap injection used ever, but it's pretty common. Another thing that's not really a vulnerability, but something that you don't really want to have is this thing, directory listing. I think Jack might have talked about this a bit last week, but basically the idea here is if you go to some directory on a website, you can just see the name of every file that's in there. This is basically bad if you have some sort of sensitive info in your website that you don't want to be public, like you're not linking to it anywhere, but it's still there, might be under some sort of secure firewall name. But if the directory is just open, people can just go to the directory and see it there. The middle line here is a Google dork that you can run, to search for websites that have directory listing enabled. So basically if I type in intitle:index.of and then asterisk, we can find plenty of websites that just have directory traversal available. For example, this is kind of what it looks like. This is something that a lot of professors do for their classes and a lot of software developers do for like maintaining old versions of software. So it's not like inherently bad, and sometimes it has its use, but maybe that this specific website didn't want us to know that there is a CMD folder. And there's just a bunch of PDFs, so probably not. But this is something you can do, like, I think I found some things on Iowa State's website where they have open directories that probably shouldn't be there. Like, for example, though, if you want to look back on WordPress content for some website for the last 10 years, you can. I'm sure they don't want all of that public, but maybe they do. Not the most useful thing, but something to just disable if you're not using it. To fix this, you're going to have a file in your website called .htaccess, and you just kind of want to include this little line that says options indexes in the directory that you don't want traversal to be in. So in this case, if you're running something out of var www and we don't want directory traversal enabled or directory listing, we'll just add this line that says, this top line that says options indexes, and then you're good to go. Two tools that can be used to try to find sensitive information that websites are running that they probably shouldn't be are Derb and GoBuster. They do the exact same thing. GoBuster is just faster, Derb's just easier. Derb is single-threaded, GoBuster is multi-threaded. The idea here is this kind of, you throw it on a website and it'll try to scan that website for common files that probably should not be exposed to the public. For example, if you're writing something like /admin and it's just an admin prompt, you don't have to log in or anything, that might be bad. Or WordPress admin, if it's WordPress, it's a good sign that it's a WordPress app, and then you can kind of start thinking, how do I attack WordPress from here? And something like that. There's 2,000 or so of these that it'll try, so you're probably bound to find something. This could just be something information leakage, like it tells you some things about what the server's running, or it could actually just be free access. So to demo this one's going to be at the terminal. So I'll zoom in. So to run this in GoBuster, you're going to type the command GoBuster followed by dir to say we're searching for directories, and then the URL of the target. In this case, it would be 10.26.2.187. It's running on my laptop, so I said localhost, and then from there you want to define the word list you're going to use. And in this case, we're just kind of using the default one that has about 2,000 or so. We're going to run it, and it's going to immediately finish because GoBuster is fast. And to highlight a few of these, HT access, HT password. We'll cover what HT password is later on. That's a sensitive file that if that were readable, in this case, we get a 403 error. So it exists, but we can't read it, which isn't all too bad. One to highlight here is a robots.txt. Robots.txt is a file that is made for web crawlers to go to. The idea with this file is that a web crawler, when they're visiting a website, they will go to robots.txt, and that file will say, hey, don't index this directory for some reason or another, which is a good sign to hackers that, hey, go to this directory, there might be something interesting there. And these are just public files you can go to. For example, if I just go to Iowa States, the robots.txt file, two interesting things that you'll find here. First one is don't go to 00 deleted. I wonder why. That one's actually dead. I'm not too sure what that's in there for. But the one that was kind of most interesting to me is a legacy admin, which I don't know why that's there. If you go to that page, it will try to have you authenticate with Okta, so it's not just some sort of free admin thing, but it's something interesting to look at. Good thing is just trying to attack to see if they're hiding something in, kind of like, I guess, hiding in plain sight is a good way to say it. I'll show Derb as well. So GoBuster, kind of a long command. Derb is just a lot more straightforward. This Derb in the name of the file. This one takes a little bit longer. In this case, they were both instant. So, like, it doesn't matter. They do this exact same thing, but GoBuster is a little bit faster. Another thing that you might have running on a website, if you're running in some sort of modern web framework, like if you're using something like Django or Flask, which are both written in Python, or Sinatra, which is written in Ruby, then it might be in debug mode by default. And if a website's running in debug mode, then one nice feature that they have is that you can go to /admin or something similar to that, and now you just have a shell that you can run Python commands in. You can't really see it in this picture, but in this case, they're just running simple, like x equals 1 plus 2 print x, and it prints out x33, which, cool, but again, you're already running commands. From here, you can just run some simple Python commands to get a reverse shell going, and then, yeah, now you're on the box. So, something you kind of definitely want to avoid when you're developing a website, when it goes on the internet, and it's actually like time to go, then you want to make sure that debug mode is set to false. And all you got to do if you're running, in this case, the example is for a Django application. Django has a file called dev.py. In there, you might see a line that says debug equals true. Just set that to debug equals false, and now you won't have admin shells anymore. Debug mode does a few more things, like it prints out I guess, like stack traces, and it might leak some information about like what version of Django are you running, or stuff like that you just don't want the public to see. So having debug mode defaults is something you're going to want to absolutely do with more modern web, or I should say web frameworks, I guess. Another thing, file permissions. If you're running a website and it has to do something like connect to a database, then it needs to have credentials for that database that it can read. And kind of the way that you do this is you create a file called a .dbconfig, which contains the username, password, and location of the database, so that the website can, whenever someone like tries to log in, it can connect to the database and then run its database query. If you just leave it public, and if you don't lock it down, then anybody visiting your website can just go to /.db_config, and now they can see your database credentials. In this case, this isn't just true for like dbconfig. Some examples, or the ones that GoBuster found, .htaccess and .htpassword. htaccess is just kind of server configuration stuff, but htpassword, again, that would be holding confidential information, so you don't just want anybody that knows how GoBuster works to run against your website, and then all of a sudden they have passwords. So to fix this, again, this is just a simple matter of going into configuration files and saying, don't make it readable. In this case, for Apache, if you'd edit your apache2.conf file, you'd have a section that looks like this, where it's a files match followed by the name of the file. In this case, it's actually going to say match on a regular expression for any files that start with .ht. It doesn't have to be that complicated. You could just say files match, and then in quotations, .dbconfig, and then just say require all denied. So when people try to visit your website, they will just get a forbidden 403 forbidden error and try to access it. And then your web app can still read from the file to get the database credentials. Might want to start turning the camera off of me, William. I don't know how. Let's try to turn the microphone off as well. The website was actually posted in SecSM Slack about 1.5 years ago, and it's still not fixed. All right. Some ways that if you have a web app and you want to like secure it or try to find weaknesses in it are through web app scanners. Basically, they just kind of scan the website. They look at all the user input, and they'll try to see how many vulnerabilities there are, and they will rank those vulnerabilities from high to informational. If anything's high, you're definitely wanting to fix it. Medium, probably. Low and info are usually just like information leakage and aren't super important. And you can probably find like low and informational vulnerabilities if you just scanned any like popular website. Two that are really popular are Owasp Zap and Nikto. Owasp Zap has a nice, fun, GUI front end, and Nikto is kind of the opposite, where it's in a terminal and it's fast to do. Both of these aren't perfect. They won't catch everything. So if it comes back and it says there's no vulnerabilities, don't take that to be the truth. Just try harder, I guess. But it's a good starting point if you're given some web app and you're trying to say where are the vulnerabilities at, and it might find something. And then I talked about WAFs last semester. This is kind of another way as a blue teamer to secure your websites. WAF is a Web Application Firewall. The idea here is that it will look at incoming requests, and if it detects any requests that are malicious, it will drop them. And I'd say these work about as well as antivirus works, where they don't. But if you have a free version, it's better than nothing. If you have a paid version, it's going to be a lot better. But either way, a skilled hacker knows how to get around them. There's so many ways you can avoid web application firewalls. One came out today where if you're doing command injection, you just include some bash variables that don't resolve to anything in your command, and it will make your input pretty obfuscated, but it won't actually change anything. And some other ways can be just to change things from like a UTF-8 encoding to UTF-16. And some other examples for things like SQL injection. A lot of people for injections will just do the classic or 1 equals 1. But there's nothing that says you have to. All that matters is that the second statement is true. And that can be anything like 2 equals 2, 3 is greater than 2. And catching all of these examples is hard to do as a WAF developer. So that's kind of why if you just obfuscate your payload a little bit, then it won't work. So one I saw the other day, it was something along the lines of like, doing this is valid SQL injection in some way. So there's just so many ways to do it that you can't really rely on a WAF to adequately secure a website. There's no substitute for just having good code. But they're not, like, there's no downside to it. If you're doing a cyber defense competition, I would recommend you install mod security. It's free, and you can set it up in like under an hour if things go well. But don't use that as an excuse to get around securing code. All right, so that's kind of all I had for this presentation. There are a lot of different ways that you can practice web app security online. The one that we walked through earlier in this presentation was DVWA, the damn vulnerable web app. This I only covered probably like half to a third of the things that are on that thing, and I also only covered the easy difficulty. If you want to continue doing this on your own, it takes about 10 minutes to set up if you know how to use Docker. If you don't know how to use Docker, you only have to just copy and paste like 2 lines of Docker commands, so it's pretty straightforward and a good learning experience. Another really popular one is Natas, which is part of Over the Wire. I don't know if we've mentioned Over the Wire this semester or not, but it's basically kind of a series of increasing in difficulty war games that will walk you just kind of through things like how to use Linux, how to do crypto attacks, how to do system escalation attacks. And the one that they have for web applications is called Natas. I want to say there's about 25 different levels or so. I don't think I've ever finished it. I got about halfway through and kind of forgot about it, but it's good. I've enjoyed it. Another popular one is Owasp Juice Shop. This was written entirely in JavaScript. There's about, I want to say, 100 or so challenges on this web app. Again, this is another one where you just kind of download it and run it in Docker. And it has, I think, 9 tiers of challenges, ranging from 1 to 9, with about 12 in each range. It also has tutorials for walking through some of the tier 1 challenges, so you can spend a lot of time on Juice Shop and learn quite a bit. I was doing that until I had to reformat my drive, but it was a good time. I would recommend it. WebGoat you will do, I think, in 231. I don't know if that's still the plan or not, but it's kind of another series of vulnerable web apps you can try to break into. And then Portswigger Web Security Academy. I just learned about this like an hour ago. Portswigger does a lot of web app security as a company, and there's a free course they offer called the Web Security Academy. You just sign up with an email address, and then you can have access to about 100 or so demos. I didn't do this yet, but it looks pretty useful. And I would recommend that even if you're just like stuck, then it doesn't hurt to just read write-ups anyways. Like, it's a learning experience. It's not like you have to prove anything. So if you get stuck on a level, just read a write-up and then go from there. And that's the point, is to learn. But if you get to the point where you're just kind of like copy and pasting commands, you don't understand what's going on, then you've probably cheated a bit too much. I think that's the last slide. Any questions about any of that? All right, cool. Thanks, everybody. And with that, I will pass it on to Jack, who's doing a beginner's guide on networking. Do you have the slides?
Yes.
Okay, good.
Imagine leaving us to go to some classes.
I know, imagine having a class at 6:10 on a Monday.
Yeah, why would you sign up for that?
Because it's a required class. It's probably going off in spring. Still gonna figure out what we're doing next week.
I'll harass Blakely.
Have fun, George.
I'm in charge? That's dangerous.
Don't burn the place down.
Yeah. All right, hello everybody. this is our beginner's night on networking that we do every semester as part of our old series of Hacking 101 slides and presentations. This is designed to be very free form and informal, as are all of my talks, though I didn't design this one. I think Keen did way back. Anyway, if you have any questions at any point, shout them out, interrupt me. You know, I want people to be somewhat involved in this, because otherwise we're just going through some kind of boring slides. Oh, there's a fun thing that I usually remember to do, and that is to kill Slack before I start this so that people can't make weird things appear on my screen. Let's just pretend I know what I'm doing. All right, so I'm just going to jump right into things. Hands up if you've ever seen this before. Osi Layers stuff. Yeah, that's pretty fun. Basically, here's your 7 layers of how things are connected. At the most basic level, you have an actual wire or airwave, wave in the air that's carrying data. And as you work your way up, you have higher and higher levels of abstraction, where you eventually get to your application stuff. There are some people who would argue that this model is somewhat outdated. There's a TCP IP model out there that I think is 5 layers that you learn, I think, in 530 or 5, and that one is a bit more relatable, since I mean, never once has it mattered to me that, you know, the data layer of something, or the I don't know, differentiating between data and network layer or anything like that, or application versus presentation. Sure, there are technical differences in there, but it's never been a huge part of my life. Never lost any sleep over the layers of the OSI model. Oh, fantastic. I forgot we put this slide in. So the TCP IP layer model just condenses the top 3 into one layer and the bottom 2 into one layer. And then renames network to internet. But in general, same basic idea. You have at your lowest level the actual the physical wires that make up the network, the wires and devices, and then the idea of how they're all connected, what they're using to talk to each other, and then all of the actual data that is being sent back and forth. Now you've got this thing on hardware addresses. Media access control is a unique identifier that every network-enabled device is going to have, and every device is going to have a, like I said, unique identifier. So there's 2 to the 48 possible combinations. That big number of numbers, that big number. These MAC addresses are never used to address anything over the public internet, anything like that. They're only used for local network stuff. And I think in 230, you have to play with this, but we look at the organization unique identifier, which is the first 3 parts of this number, which, you know, Cisco has, like every Cisco device ever produced is going to have, not every Cisco, I think they have a couple different OUIs assigned to them at this point, but, you know, every Cisco router is going to have the same first 3 octets, and then the second 3 are going to be different on a per device basis. And like that says there, they can be changed and spoofed. If you've ever been in an airport that lets you get on the Wi-Fi for up to half an hour for free, and after that they want you to pay, more often, almost certainly what they're doing for that is just making a note of your MAC address and saying that this device got on at this time, and in 30 minutes we're just going to stop routing their traffic unless they pay us. So, you know, it takes all of 2 seconds to run MAC changer on Linux and give it a new MAC address, and then you just disconnect, reconnect, and it'll think you're a brand new device. So, you know, don't pay for internet in airports. That's a ripoff. The idea of internet protocol. This is a classic right here. Basically, exactly what it says on the tin. I mean, this is how everything knows where. This is how we keep track of everything on a network. Later in this presentation, it gets more into the differences between publicly routable networks and then the private networks, and then how you would use a network address translation to go between those. But yeah, I suppose this top graphic here, it's kind of a graphic, is far more familiar to everybody than this bottom one. IPv4 is still, what we're using for pretty much everything. IPv6 is supposed to have taken over for something like a decade now, and it just doesn't. It's like the year of the Linux desktop. We all want it to come here, but it has yet to materialize. IPv6 is interesting and also less complicated than everyone acts like it is. If you want to have some fun, I know we've talked about this in previous meetings, but Iowa State has the routing infrastructure in place for you to claim a block of IPv6 addresses that you can use for whatever, but they don't really manage it at all. So I know some people who have run Minecraft servers that can be hit from outside Iowa State, like that can come in through the firewall that's supposed to never allow anything into the network, by just giving people their publicly routable IPv6, because that's part of the IPv6 shtick. I don't totally understand it, but my rough understanding is that they are supposed to be unique to every device, since they're based on MAC addresses, so they can be used both for local networks and public network routing stuff. So I don't know, you can have some fun with that around here. Questions so far? Cool. I believe you were just given a block as a student. I think I'm going to admit that I don't know very much about IPv6 stuff, but if you ask Jacob Moody, he knows a lot about it. But my rough understanding is that you as a student are just given a slash, I can't remember what the actual, how many you're given. I think it's like, I actually don't remember how many addresses you're given. But a bunch of organizations I don't know if they claimed some or how that whole process has worked, because I think it is tied to MAC addresses somehow. I will acknowledge that I know next to nothing about it. Ask Moody. I feel like that's my response to 80% of what people ask me these days, but yes, I believe the university just gives you some that you're allowed to claim and use for yourself. Net masks, here's everybody's least favorite part of Computer E230. Basic idea is that you are representing bits for, or you're using these values to represent, how many hosts are going to be on some network that you're on. The basic idea is you turn the octets into your binary ones and zeros, and that helps you understand it somehow. I'll be honest, I don't totally remember it. The big things that I know about, the only things that I've ever had to care about for net masks are these values right here. The idea of a /24, a /16, and a /8. Basically, if your local network is a /24, you have 254 hosts that can be routed to on it. All of them will have the same first 3 octets the same, and then the last one will go from 0 to 254, and then you have your broadcast address and stuff at the top. /16, same deal, except your last 2 octets can change, and a /8, same, but your last 3 octets will be different, and only the first one will be shared across all of them. Basic idea is that when the octets are at 255, that's all the ones in the binary representation, those get locked into place, stay the same across all the hosts, and the zeros are where they can change. Some actual examples, better than me just kind of rambling and gesturing with a marker. So Iowa State's internal 10.0.0.1 through 10.255.255.254 is a /8, because everybody's internal network IP address is going to start with 10 dot something, and then the next 3 are seemingly arbitrary based off of what netreg gives you. You can see that there's 16.7 million hosts possible with those 3 octets changing, and then just 10.0.0.0 is the network address, and 10.255.255.255 is the broadcast address. Then here's one of Iowa State's publicly owned ranges, 129.186.0.1 through that 255.254. That's a /16 with 65,000 hosts. So, yeah, which we'll get to that in a slide or two, but that does look strikingly similar to a pretty standard issue private network range for internal networks. Iowa State owns one of the most annoyingly confusing IP or set of octets that we could possibly get. But basically, I'm going to do this slide out of order just because I've started talking about it. Iowa State owns 129.186, which is strikingly similar to the 192.168 that is the standard for like home routers to use for their private range, which sucks when you're in 230 and trying to learn this for the first time, and you are both pinging the Iowa State website to figure out what their network range is, and also setting up your internal network range for the class and wondering why the hell it's all the same. But yeah, Iowa State owns that. The idea of the public versus private addresses, there's these 3 blocks that are reserved for private ranges. There's, according to RFC 1918, you shouldn't be able to ever publicly route something to 10 dot anything to 172.16, or 172.16 to 31 anything, or 192.168 anything. Those are meant to be reserved for private usage. Most businesses I've seen, or large organizations, stick with the 10 dot just because that gives you lots of flexibility for hosts and setting up subnets in very nicely organized ways. And then most home routers will, most consumer grade equipment will default to 192.168 ranges. Routing, I love that this slide doesn't have any text. I just kind of have to improvise off of a picture. That's kind of fun. Essentially, I think what the point they're trying to get at here is the fact that you have your devices, you've got a user's computer and a server that are talking to switches on their local network that go up to, or they're plugged into a switch, like in the same room as them, and then their routers connect them to this 172 private network. I'm hoping that some text comes up with a nice bulleted example of just walking you through the steps of how, if PC1 wants to talk to server 0, how it'll query the router 1, which will query router 0, which will return everything. Excellent. This kind of helps. Routing tables. Essentially, if you can see on the right here, or I guess on your left, if you are PC0 and you're trying to get to what is this even? Doesn't say where it's trying to go to. Well, basically, computers will keep track of the destinations that they're trying to hit and the hops that they have to send traffic to, and whenever they have traffic that needs to go to, any of these ranges, they'll know, okay, I just throw it at router 1 and it will handle it for me. This network address translation is fun stuff. Essentially, this is how you can have all of us on the Iowa State network all talking out to the real world at once, and not having weird issues of, every single person on campus has 3 different tabs open to, Twitter. They can keep track of all the different sessions with the fun that is natting and NAT routers. Essentially, everybody inside the network will query the router to go out of the network, and they'll have, inside one will have a session with NAT router, which manages the session between itself and the outside service, and it just opens it up on some arbitrarily high port and just handles all of that for everybody, which is nice. But yeah, it'll allow, numerous users behind one or a small range of public IP addresses, which is, necessary for communicating over the internet. Let's see, so network layer protocols, IPv4, IPv6, like we were talking about, ICMP, your pings and stuff like that. Transport layer stuff, you have TCP and UDP. Basic difference, you've probably heard the really horrible, stupid joke of, I'd tell you a joke about UDP, but you probably wouldn't get it. And then everyone goes, ha, that's hilarious, because UDP is connectionless, and it's typically used for things like video streams, where you don't want to have a whole handshake and whole communication process for every single packet. You don't care if a single frame is dropped. You just want to throw traffic at the destination and let it go. And TCP HTTP is connection oriented, where there's the whole handshake that we've discussed, and every packet has to be accounted for. If anything gets dropped, the client will complain and say, hey, you said I'm supposed to get packet 47 in between 46 and 48, didn't get it, send that one again. Which is why video streaming on something like YouTube is substantially smoother than it is on Netflix, at least in my experience. But there's a real reason for that. Most video streaming services that don't care about digital rights management stuff will use UDP, just because something like a Twitch stream is just going to be either packets thrown at the wall and hopefully they get through to you. Netflix and Hulu and stuff like that use TCP for their video streams so that they can do fun things with DRM and make sure that every packet is accounted for, and things are encrypted in fun ways. And I don't understand all of it. It's just annoying when that will start buffering and be slow. Application layer stuff, you have DNS. If you've taken 230, you've probably heard us say at length, it's like the address book of the internet, and then not credit Matt for saying that. HTTP and HTTPS, or mostly, HTTP and HTTPS are the protocol that web browsers and web servers are using for displaying web pages. FTP, your basic file transfer protocol. SSH, secure shell. SMTP for sending email. IRC, internet relay chat. I'm not going to get on my IRC soapbox, but people should be back on IRC. It's good, and I don't apologize for that. Questions about any of that nonsense? Linux networking basics. I'm just going to kind of run through this somewhat quickly, but long story short, these are various commands that you can and should use on Linux boxes for configuring networks. So you have ifconfig, interface configure, I guess is how that spells out. But you run that, it'll tell you information about everything, all of your active network interfaces. You can specify an interface name, tell it to put them up and down. If you've taken a 230, 231, you've spent a lot of time saying ifconfig whatever down, ifconfig ENS 160 down, ENS 160 up, to turn your Ethernet connection off and on again. You can also do things like assign a static IP address to a certain network interface, or assign a network mask to an interface if you felt like doing that programmatically through a terminal emulator instead of just setting them all in a configuration file. If up, if down, faster way to do that. I will also throw out, these do not all work on all Linux distros. Some, I think Debian and Ubuntu have moved to using NetPlan for stuff, which uses different commands, I think, kind of. I don't actually totally know. I know that the config files are different, so I just assume everything is changed and scary, and I hate it. Different Unix likes will use different commands, but these are pretty general. I'm not going to say universal, but a lot of machines will use stuff like this. Route displays the local IP routing table. This is important if you really care about setting static routes to specific hosts or networks for some reason. You have the power to do that. Netcat, this is particularly useful and fun. This comes up in CDCs a lot. You can use Netcat TAC-L and a local port, and it will start listening on that port, and any data that comes to that port, it'll just print out in your terminal. You can also just echo stuff into Netcat, or cat stuff into Netcat, and tell it a remote IP address and port to send to that, and it'll just throw those across the network. Where they come in CDCs is that it is one line it's a one-liner command to set up a reverse shell using Netcat. Netcat TAC-L for listen, give it the port to listen on. TAC-E for execute, bin bash. TAC-I think is interactive or something. It's been a hot minute since I've done that, I'm gonna be honest, but long story short, listens on a port, anything that comes in, it'll just execute that through bash. So it's pretty frequent that you'll find that on CDC machines, or if you're doing something like what Cole was demonstrating earlier, you were able to get remote command execution on, or just any sort of command execution on a box. Then you'll just tell it, hey, open up a port and start sending that to bash for me, and and you'll be able to start abusing that. Yeah, I don't know. It's useful, fun stuff. It definitely comes up pretty frequently for if you just want to listen in on a stream of data coming off of a certain service. Dig and NS lookup, and host, which I've literally never used, but dig and NS lookup are huge for DNS queries. Use those in class a lot. Use those at work a lot. They're really nice for setting up if you're able to get a list of all the subdomains that belong to a client company or something that you're working on, you can just real nicely set up a dig script to go through and check if every one of those actually does have DNS records currently existing, which gives you some good indication if they're really using it right now. Let's see, ping and traceroute, pretty straightforward stuff. If you've ever used ping before, I'm sure you've all used ping before to check that your internet connection is working. I'm sure you've also tried to do that in the Ice Age environment, to try and ping Google and remembered after a minute that that doesn't actually work because ICMP traffic isn't allowed out. But ping just tells you how long it takes for you to hit some service or some box somewhere else. Also, traceroute will do a similar thing, but it will give you the route the packets went. I think Julie gets into it in 230, but the way traceroute works is actually pretty, reading up the just like 2-paragraph explanation for how traceroute works is actually pretty neat. They did some clever things to make that function. Netstat, another 230 and CDC classic, just display all of your current network connections with the right flags, which can be annoying to remember. The one to remember is netstat tac plant, netstat plant, and that will give you all of the processes that own the listening and I guess just all active connections. L and A are unnecessary together, but it's easier to remember. I guess you could do netstat pant, process that owns all, or processes that own all active TCP connections and the numeric statistics for them. And then that makes it real easy to grep through, figure out what's talking on what port, what's doing malicious reverse shell things, stuff like that. Telnet, just a reverse or a remote session on some server somewhere, but plain text and bad. Take 230 if you haven't. Take 489, 530, and 541. I have not taken 489, but I think that's the network programming class. I can tell you that unless they've changed something major recently, definitely, I'm kidding, this is in Minecraft for the camera. This isn't real at all. You can root the Linux boxes in the Coover Labs in that class, because they give you pseudo privileges for Wireshark, which is exploitable. 530, Doug Jacobson class, a lot of fun. 541, don't actually know what that is. Questions? Excellent. If you have networking questions in general, netstat man pages are your friend. They will walk you through a lot. Also, just general any Linux documentation on the internet tends to be better at answering these questions than I am. Thank you for tolerating me. Yeah, thus endeth my improvised beginner's night. Thank you for coming.